this is just a quick review of the check-in that we did in class. So first of all, we have minus 5, and inside our bracket we have the complex of -3 and -2. And what I'm going to do is I'm going to rewrite everything except for the -3 and -2, and I'm going to compute that complex and leave it in a bracket. And that ends up being 6. So then we have -5 times 4 minus 6, which ends up being -5 times 2 negative. So multiply those two together and we get 10. Now let's take a look at the next problem. So we've got, well, 4 minus 6, and then we're going to plus, well, the result of -3 times -7 is -21, and we're going to write minus 19 over 2 for the division, and then we're going to compute the very bottom to be -8. Now let's bring these three whole numbers together. So we get 4 minus 6 minus 21 minus 19 over 2 divided by -8. So -4 minus 6 is so 4 minus 6 is -2 minus 21 is -23 minus 19 over 2 divided by -8. So on the top half of our fraction, we're going to have another fraction, and that's going to be, the common denominator is going to be 2, so we're going to have -46 minus 19 over 2, all divided by -8. When we continue calculating, we're going to find out that we have -65 over 2, and we're going to change that over, that fraction part, into a division of -8, which ends up being -65 over 2 times 1 over -8, which simplifies to 65 over 16 as our final answer. Continuing with the problems, now we have a fraction to work with for question number 3. To start, 1 3/4 becomes 7 over 4. And then we have, well, 6 times 3 is 18 plus 5 is 23, so the top is -23 over 6. The LCM in this case is going to be 12, not 24, because 12 can be divided by 6 and 4. So I must multiply this by 6. No, not 6. We multiply this by 3 and this by 3. Now, the 23 over 6 must be multiplied by 2 and 2. Our next line will be 21 over 12 plus -46 over 12. Now, using the simplification of our plus and minuses, we get 21 over 12 minus 46 over 12, which ends up being -25 over 12. And you can leave your answer in this form, in improper fraction form, unless I tell you explicitly. So now let's take a look at question number 4. before we begin, we need to get rid of all of the extra pluses and minuses in our bracket. So I'm just going to write, well, if I look at the first part of this problem, I know I'm going to eventually have to change 2 1/5 into an improper fraction. So I'm going to do that right now. So that ends up being 11 over 5, because 2 times 5 gives us 10 plus 1, which will give us 11. Now, let's continue. Now we're going to be dividing by the quantity of negative 3 over 4. Now, you'll notice that we have a plus and minus in this complex here. We have a minus in this complex and a minus sign in between these two brackets. We can put these two together to get plus 7 over 10. Now, for inside the bracket, the LCM is 20. So what we're going to do is we're going to multiply the 7 over 10 by 2 over 2 and the 3 over 4 by 5 over 5. So now on our next line we get 11 over 5 divided by negative 15 over 20 plus 14 over 20. Adding those two things in the brackets ends up giving us the quantity negative 1 over 20. The next thing that we have to do is we're going to have to flip and multiply 1 over 20. So we're going to have 11 over 5 times 20 over negative 1. Now let's cross cancel. 20 and 5 can be both divided by 5, so 20 divided by 5 is 4, and 5 divided by 5 is 1. Multiplying the numerators, we get 44 over negative 1, which simplifies to negative 44, which is what we expect. Moving on. So now we need to apply distributive law to this first problem, question number 5. So basically what I want you to do is you're going to apply the distributive law to everything. And you'll notice that in this complex here we have a minus 3 and a x plus 2. So what we're going to do is we're literally going to take minus 3 and we're going to apply it to everything on the inside of the bracket to get rid of our brackets immediately. So we're going to have 4x plus 4 plus 4 is 2x minus 8 minus 3x plus 6. Now, a lot of you have the tendency to go and start moving numbers back and forth, but that only increases the complexity of your problem. What you want to do is you want to chunk the problem by focusing on one side and collect all its like terms, and then collect the other set of like terms, so that when we go about moving numbers and variables across, we have less work to do. So let's do that right now. So we're going to get, on the left side, we're going to get 4x plus 8, which is equal to, well, 2x minus 3x is minus x. Negative 8 plus 6 is minus 2. Now we'll move all the variables to the left side. So we have 4x plus x. I'm going to cross those out because minus x becomes plus x when I move it to the other side. And then we're going to have minus 2 on this side. And then we're going to subtract 8 here, which ends up being negative 10 on the left side and 5x. Now, in order to get x by itself, we just have negative 10 divided by 5, which gives us negative 2. And x equals -2 in the end, and we're done. For question number 6, you need to multiply by the lowest common multiple, and the LCM in this case is going to be 6. So we're going to multiply each of these numbers that are in this equation by 6. So let's do that right now. So we're going to take -1 and multiply by 6. We're going to take a over 2, and we're also going to multiply it by 6. And 2a over 3 is also going to be multiplied by 6. Simplifying, -1 times 6 gives us -6. Now, 6 divided by 2 gives us 3 over 1. So our final answer for a is going to be plus 3a. Now let's cancel again. Now we have 3 and a 6, and that gives us 2. So 2 times 2 gives us 4. A on the right side. So now let us move all our variables to the right side in order to avoid minus signs. So we have 4a minus 3a is equal to -6. So I'm just going to cross those off like we were doing before. And yes, we have a equaling -6 as our final answer. Now let's move on to the final problem of the day. The first thing I need to do is I need to look at this problem, and what we have to do is we're going to take each of these multiplication complexes and we're going to distribute as much as we can. So for the first bracket, our results are going to be based on this distribution here, 3x into all those three parts. So we're going to get 3x cubed minus 3x squared y plus 3xy squared. You'll notice that as I'm doing my calculations, I tend to take the time and organize my multiplication in terms of x's first, then y's. What that will allow me to do later is to quickly see the patterns that match, i.e. the terms that match. The second half of the problem is going to require us to multiply -2 into everything into this bracket here. So we're going to take the -2y and we're going to hit it with this and this and this. Be sure to always flip the signs as you're moving as well. So -2 times 2y squared gives us minus 4y cubed. And then minus 2y times 3xy. So there's no x's in our multiplication except the 1. And we also have -2 times 3, which gives us -6. And then I've got x. And then the number of y's that I have is going to be y squared. There's 2 of them. And now let's do that again for the last term. -2y, and then we distribute into -x squared is going to be positive 2, well, x squared, how many y's? Only 1. And now on our next line, before we do our substitution, you need to start organizing your variables from left to right. So the first variable I'm going to organize is 3x cubed, and you'll know that I automatically cross that off as soon as I write my variable down. Now the next term that I have over here is I just look across and I have the x squared y terms. So we're going to go and take a look for the x squared y terms. So we've got 3x squared y we got negative 3x squared y and a 2x squared y. Negative 3 plus 2 gives us minus 1. So this part turns into minus 1, and the moment that I've done with those two, I cross them off. The next term I work with is xy squared, so we'll do that. So we have xy squared, and so now we look for all our xy squared terms. So here's one, and here's the other one. So 3 minus 6 gives us minus 3 xy squared, and I'll cross those off, and all we have left is the minus 4y cubed. I'm just literally being very meticulous with my calculations here in order to cut down on the amount of work I have to do. So now let's do our substitution. So now we get 3 bracket negative 2 cubed minus, well, negative 2 and y is negative 2 squared times 2 minus 3 times negative 2 squared minus 4 2 cubed. Alright, now you'll notice that each of these multiplication complexes that we have here have minus signs in between them. What you should do is just calculate the minus signs in between, and that's it. When you calculate each of those complexes, what I want you to do is I want you to make sure that you put the result in a bracket and then distribute the minus and plus signs appropriately. So 3 times negative 2 cubed is negative 8 times 3, which gives us negative 24. And notice I'm going to put that in a bracket. I'll put it in blue this time. And then we have a minus. And then inside that bracket, we have negative 2 squared, which is 8, is 4 times 2, which gives us 8. Minus, let's see, the result of that complex is going to be, well, negative 8 times 3, which is going to be negative 24. And for the final complex, we're going to have 4 times 8, which is going to be 32. Now let's use our distributive properties on all those minus signs and get rid of them. So we got minus 24, minus 8, plus 24, and minus 32. So the minus 24 and the plus 24 cancel. So all we're left with is negative 8 minus 32, which is negative 40. We're done.